Hello and welcome to CAPACITOR Academy, the intellect on YouTube. In this channel, we are out to help the advanced level science students to attain their academic excellence and their academic goals by providing them with the correct and the time-saving approach to all GCE questions as proposed by the GCE board. And we do that in all the science subjects because we are a team of teachers that performs that function best. In this video, we are looking at June 2021 advanced level physics paper 2. And before I continue, I would like you to subscribe to the channel and activate the notification bell to not miss any of our videos uploaded subsequently. So the question with figure 1 shows how 3 capacitors are connected in a circuit. Given that the total charge stored on the capacitors is 1500 microcoulomb, with the switch closed and the potential difference between A and B is 12.0 volt. And I've represented the figure A. Calculate the Roman 1 total capacitance in the circuit, Roman 2 value of X, Roman 3 potential difference across the 60 microfarad capacitor. B. The supply is disconnected and the capacitors discharged through the 15 kilo ohm resistor. Then calculate the total time taken for the potential difference between A and B to fall to 6.0 volt. Okay, let's go directly to the solution. First of all, we present the diagram so that you should have a clear view. Now, A, they say we should calculate the total capacitance. If you remember in the question, I've given us the total charge stored on the capacitors. So it means that, and if the value is 1500 microcoulomb. So to calculate the total capacitance, we calculate it from Q equals to CV. From Q equals to CV, we have that C is equals to Q all over V, which is equals to 1500 microcoulomb all over 12 volt, which is equals to 125 microfarad. Now the value of X, calculating the value of X. Now we see that the 20 microfarad and the 60 microfarad are connected in series. So we calculate the combined resistance in series. And to calculate the combined resistance in series is the same formula as to calculate the combined resistors in parallel. So to calculate combined resistance in series, we have that CS is 20 microfarad times 60 microfarad on 20 microfarad plus 60 microfarad, which is equals to 15 microfarad when you calculate it properly. Now we realize again that X is connected in parallel with both of them, both of the 20 microfarad and the 60 microfarad capacitors. So the total capacitance there can be estimated to be that the total capacitance CT is 15 microfarad plus X. Now to calculate X, we simply have 125 microfarad plus or is equals to 15 microfarad plus X, and which implies that the value of X is 110 microfarad. Roman 3, the potential difference across the 60 microfarad capacitor. Now, to calculate the potential difference across the 60 microfarad capacitor, we know that the charge stored across the series connection in capacitors are the same. So the charge that the 20 microfarad capacitor contains is the same charge in the 60 microfarad capacitor. So we should first of all calculate the total charge. The total charge stored in the 60 or in series, that is the same thing, will be Q is equals to CV, and C, which is the combined series capacitance, is normally supposed to be CS, which is 15 microfarad times 12 volt, which is equals to 180 microcoulomb. Now to calculate now the potential difference across the 60 microfarad, we recall that capacitance in series stores equal charge. Hence the potential difference across the 60 microfarad capacitance or the 60 microfarad capacitor will be equals to Q all over C, and which will be equals to 160 microfarad microcoulomb all over 60 microfarad, and which will imply that V across the 60 microfarad is 3 volt. So that what you need to remember is that the total charge stored in series is the same. So we have Q equals to CV. First of all, calculate total charge stored in series before you now calculate the potential difference stored in the 60 ohm capacitor, because the potential difference stored in the 60 ohm capacitor is not the same potential difference stored in the 20 ohm capacitor. So we calculate it using this way. Now the other part, the B part of the question, the time taken for the discharge simply. So we are in the discharging process now. from Q equals to Q naught e to the power negative T all over RC. That is the formula for the discharging of a capacitor. But we know that Q is equals to CV. So it means that our CV will be equal to CV naught e to the power times e to the power negative T all over RC, which implies that V is equal to V naught times e to the power negative T all over RC. Now here we'll now play with arithmetics. We know that the initial voltage is 12 volts. V, the voltage that they give in the question, they said calculate time taken for the voltage to fall to 6 volts. So V is equal to 6 volts. R is equal to 150 kilo ohm. C is equal to 125 microfarad. So it means that when we substitute it there, we have V all over V naught is equals to e to the power negative T over RC, which implies that when we take the link on both sides, we have link V all over V naught is negative T all over RC, which will imply that our T will be equals to RC link V naught all over V. Now you ask me where the negative sign has gone to. You know that on indices, when you reverse the denominators, when you reverse the fraction on the link function, then you need to include a negative. So that's why the negative have gone there. So to calculate T now, we just simply replace the values. We have 150 kilo ohm times 125 microfarad times link 2, because you know that V naught, which is 12 over 6, is 2. So to calculate now the time there, simply have that the time is equals to 13.0 seconds. So guys, we have come to the end of this video, and I invite you to like the video, share and comment. Now your comments are very, very important. In the comment section, you can tell us your impressions, and you can tell us which video you want us to be uploading more frequently.